Right now, at this very moment, something is moving through our solar system that should not exist, not according to 4 centuries of cometary science, not according to every spectroscopic database we have compiled since the 1960s. On July 1st, 2025, at 0437 Universal Time, the Atlas Survey Telescope in Rio Hurtado, Chile picked up an object at 420 million miles from the Sun, traveling at 61 kilometers per second. Standard protocol, standard analysis. Then the numbers came back. The orbit was hyperbolic, eccentricity greater than 1.0. That alone told us everything we needed to know and nothing we wanted to hear. This object, designated 3I/Atlas, had originated beyond our solar system, beyond the Oort cloud, beyond the gravitational influence of our Sunday. The third confirmed interstellar visitor in human history. But here is what kept astronomers awake for 72 hours straight after discovery. The spectroscopic signature showed something impossible. Nickel emission at 4 grams per second. No iron. None. In 15,000 comets catalogued across 2 centuries, nickel and iron appear together, always, without exception, because they are born together in supernova explosions, fused in the same stellar furnaces, expelled in the same ejecta clouds. They are chemical siblings, inseparable in nature, except here. Let that sink in. I have spent 5 decades studying the physics of the impossible, from higher dimensional universes to the thermodynamics of wormholes, and I can tell you that when nature violates its own rules, we must pay attention. The Keck 2 telescope in Hawaii confirmed it in August. The Very Large Telescope in Chile confirmed it again in September. Hubble Space Telescope imaging on July 21st showed not the expected dusty tail streaming away from the Sun, but a jet of material pointed directly toward our star, an anti-solar stream composed of carbon dioxide, water vapor, trace cyanide, and that anomalous nickel signature concentrated within hundreds of kilometers of the nucleus. The emission profile matched the chemical fingerprint of nickel tetracarbonyl, a compound with the formula NiCO4, a substance we know from exactly one context in the entire scientific literature. Industrial refining, nickel carbonyl processing, a technique developed in 1890 by Ludwig Mohn to purify nickel through thermal decomposition, never observed in astronomical settings, never detected in cometary atmospheres, until now. Think of it like this. Imagine you are hiking in a remote forest, days from any human settlement, and you find a fire. Not a wildfire spreading through underbrush, but a campfire, neatly arranged in a stone circle, burning at exactly 450 degrees Celsius. You can argue that lightning struck in a very specific way. You can propose that rare minerals spontaneously combusted under precise atmospheric conditions. Or you can consider the obvious explanation. Someone built that fire. The nickel to iron ratio in 3I Atlas is that campfire. The scientific community is now divided into 3 camps. The first camp, let us call them the naturalists, argue that 3I Atlas formed in an exotic stellar environment, perhaps around a metal-rich star that underwent unusual nucleosynthesis, creating a debris field with anomalous chemistry. They point to the carbonyl hypothesis. Under extreme cold, near absolute zero, carbon monoxide molecules might bind to nickel atoms on the surface of dust grains, forming NiCO4 naturally. When the comet approaches our Sun, these compounds sublimate, creating the observed emission. Possible? Yes. Probable? That depends on how many coincidences you are willing to stack. Here is where the improbability accumulates. 3I Atlas is not small. Hubble observations constrained its nucleus diameter between 440 meters and 5.6 kilometers, most likely around 3 kilometers. For comparison, 1I Oumuamua, the first interstellar object we detected in 2017, was estimated at 400 meters maximum, probably closer to 200. 2I Borisov, discovered in 2019, had a nucleus less than 1 kilometer across. 3I Atlas is at minimum 3 times larger than Borisov, potentially 25 times more massive. The size distribution of interstellar objects should follow a power law. We expect many small objects, few large ones. The probability of detecting a Manhattan-sized visitor before thousands of smaller ones is roughly 1 in several hundred, depending on your model assumptions. Anomaly 1. The trajectory presents anomaly 2. When astronomers reconstructed the orbital elements, they found that 3I Atlas approaches the ecliptic plane, the flat disk where Earth and the other planets orbit, at an angle of only 5 degrees. Random interstellar objects should arrive from any direction with equal probability. The chance of naturally aligning within 5 degrees of the ecliptic is approximately 1 in 360, or 0.28%, not impossible, but noteworthy. Moreover, the timing of its passage brings it within observational range of Mars on October 3, 2025, passing 30 million kilometers from the red planet, within range of Venus in November, within range of Jupiter in March 2026. Multiple planetary encounters during a single transit through the inner solar system. Each individual encounter is unremarkable. The coincidence of multiple close approaches during the brief window, when the object is active and observable, raises questions. Anomaly 3 involves the outgassing profile. The Transiting Exoplanet Survey satellite TESS captured pre-discovery observations dating back to May 7, 2025, when 3I Atlas was 6.4 astronomical units from the Sun, beyond Jupiter's orbit. At that distance, water ice remains frozen. Typical comets do not activate until they cross approximately 3 AU. Yet 3I Atlas was already exhibiting a measurable coma, a cloud of gas and dust extending thousands of kilometers from the nucleus. This indicates sublimation of hypervolatiles, substances that vaporize at extremely low temperatures: carbon monoxide, carbon dioxide, molecular nitrogen. The Vera Rubin Observatory tracked the coma expansion from 13,000 kilometers on June 21 to 19,000 kilometers by early July. The outgassing rate suggests internal reserves of volatiles that should have been depleted during any previous close approach to a star, assuming 3I Atlas is billions of years old as its galactic trajectory implies. Unless it formed recently, which contradicts its velocity and origin point, or unless those volatiles are being generated internally rather than simply sublimating from primordial ice. Here's the terrifying part. James Webb Space Telescope spectroscopy conducted on August 6th using the near-infrared spectrograph revealed carbon dioxide, water, carbon monoxide, and carbonyl sulfide in the coma. Standard cometary chemistry. But the ratios were wrong. The carbon dioxide to water ratio in 3I Atlas exceeds that of any known solar system comet by a factor of 4. CO2 is 3 times more abundant than H2O in the observed spectrum. In our comets, water dominates. In 2I Borisov, the previous interstellar comet, water dominated. The chemical composition of 3I Atlas suggests formation in a colder, more carbon-rich environment than anything in our stellar neighborhood. That places its origin in the outer regions of a protoplanetary disk around a star with different metallicity, different composition, different evolutionary history than our Sunday. We are looking at chemistry from another world. Literally. Now we arrive at the interpretive crossroads, the point where data ends and hypothesis begins. I want to be clear about this distinction because in science, speculation is not a weakness, it is a tool, as long as we label it honestly. 3 scenarios present themselves, each with different implications for what 3I Atlas represents and what we should do next. Scenario 1, the natural anomaly hypothesis. 3I Atlas is simply a comet, an unusually large one with unusual chemistry, formed under rare but natural conditions around a star unlike our own. The nickel-carbonyl signature arises from exotic but explicable surface chemistry involving metal-bearing grains and carbon monoxide ices. The size is a statistical fluke. We happen to detect a large interstellar object before many smaller ones because large objects are brighter and easier to spot, creating observational bias. The aligned trajectory is coincidence. Space is big, but given enough interstellar objects passing through over millions of years, some will inevitably align with our ecliptic. The unusual outgassing is simply the behavior of ice compositions we have never encountered before. This scenario requires no new physics, no paradigm shifts, just patience and more data. It is the conservative interpretation, and in science, we start conservative. Scenario 2, the early warning hypothesis. 3I Atlas is a natural object, but its properties make it dangerous in ways we do not yet understand. Comets can fragment. They can outburst, suddenly releasing huge quantities of gas and dust when subsurface pockets of volatile ice are exposed to sunlight. 3I Atlas is large enough and active enough that if it underwent catastrophic fragmentation near perihelion, which occurs on October 30th at 1.4 AU, the resulting debris field could pose a long-term hazard. Fragments would spread along the original orbit, creating a stream of objects that Earth might encounter on future passes, decades or centuries from now. This is not immediate danger, this is actuarial risk, the kind that appears in disaster preparedness documents and gets funding for monitoring programs. The International Asteroid Warning Network has initiated a comet astrometry campaign running from November 27, 2025 through January 27, 2026, specifically targeting 3I Atlas. They are refining trajectory models, improving position measurements, ensuring we know exactly where this object is going and whether any fragments pose future collision risk. That campaign was not routine. It was activated because the size and behavior of 3I Atlas warranted it. Scenario 3, and I present this not as advocacy but as logical completeness, the artifact hypothesis. 3I Atlas is not entirely natural. Some aspect of its composition, structure, or trajectory has been modified or designed by intelligence. Not human intelligence, obviously, but technological civilization that arose somewhere in the Milky Way engineered this object and sent it on a journey that brings it through our solar system during the brief window when we have the capability to observe it. This scenario explains the improbability stack. The size makes sense if you are building something intended to survive interstellar transit over millions or billions of years. Bigger means more shielding, more redundancy, more capacity to carry payloads or instruments. The trajectory makes sense if you are interested in planetary systems. Aligning with the ecliptic maximizes encounters with planets where life might exist. The nickel carbonyl signature makes sense if you are using industrial materials, refined metals, surface treatments designed to protect against cosmic radiation and micrometeorite erosion over geological timescales. The anti-solar jet makes sense if you are making course corrections, if you are bleeding off volatiles in a controlled way to adjust your orbit without conventional propulsion that we could easily detect. Avi Loeb, professor of Kraken, astrophysics at Harvard and former chair of the astronomy department, has assigned 3I Atlas a rank of 4 out of 10 on what he calls the Loeb scale, a quantified assessment of potential technological origin. 4 out of 10 means anomalous, worth serious investigation, but not conclusive. For context, 1I Oumuamua, which Loeb has argued might be a light sail due to its non-gravitational acceleration and extreme elongation, ranks higher on his scale. 3I Atlas presents different anomalies, not acceleration, but composition, not shape, but chemistry. Loeb emphasizes that the nickel without iron signature is chemically identical to what we produce in nickel refining through the Mond process, and that natural formation of nickel tetracarbonyl in cometary environments would require conditions so specific, so finely tuned, that invoking them feels like special pleading. Other researchers disagree. They note that we have observed exactly 3 interstellar objects total. Our sample size is laughably small. Drawing conclusions about what is normal or abnormal in interstellar space based on 3 data points is statistically meaningless. They are right. This is the heart of the scientific tension. We do not have enough data to be certain of anything. What we do have is a calendar, a sequence of observational windows that will either resolve these questions or deepen them. On October 21st, 2025, 3I Atlas enters solar conjunction. From Earth's perspective, it disappears behind the Sunday. We lose line of sight for approximately 6 weeks. Ground-based telescopes cannot observe it. Space-based telescopes like Hubble and Webb have limited viewing angles when targets are close to the Sun due to thermal and operational constraints. During this blackout period, 3I Atlas reaches perihelion on October 30th at 1.4 AU, its closest approach to our star. This is when comets are most active, when heating is maximum, when outgassing peaks, when fragmentation is most likely. We will not be watching. That is not a conspiracy. It is orbital mechanics. When 3I Atlas emerges from behind the Sun in mid-December, we will see immediately whether its behavior has changed. Has the outgassing increased? Has the nickel emission rate shifted? Has the nucleus fragmented into multiple pieces? Is the anti-solar jet still present, or has it reoriented? The Mars Reconnaissance Orbiter captured images of 3I Atlas on October 4th through 7th using the HiRISE camera, the highest resolution imager currently operating beyond Earth orbit. HiRISE can resolve features down to 30 centimeters on the Martian surface. At 12 million miles distance from 3I Atlas during its Mars encounter, the resolution was approximately 30 kilometers per pixel, roughly 3 times better than Hubble achieved. Those images will show the structure of the coma, the distribution of dust, the morphology of the jet, potentially the shape of the nucleus if it is large enough and bright enough. As of today, October 26th, those images have not been released. NASA's communications office has been affected by a partial government shutdown. Science teams have the data. Analysis is ongoing. Public release is delayed. That is not suppression. That is bureaucracy. Frustrating, yes. Sinister, no. In November, the Jupiter Icy Moons Explorer spacecraft, JUICE, operated by the European Space Agency, will turn its instruments toward 3I Atlas. JUICE carries a suite of spectrometers, cameras, and a particle sensor designed to study the Jovian system. For a brief period, the spacecraft will devote observing time to the interstellar visitor, capturing data in wavelengths that ground telescopes cannot access, and from a vantage point that provides a different viewing geometry. In March 2026, as 3I Atlas swings past Jupiter on its outbound trajectory, NASA's Juno spacecraft, currently in orbit around Jupiter, will also observe. These are opportunistic observations, bonus science during a mission designed for other purposes, but they will add crucial data points. By mid-2026, we will have observed 3I Atlas across a full range of heliocentric distances, from 6 AU inbound to 2 AU outbound, across multiple wavelengths from ultraviolet through infrared, from multiple spacecraft platforms, and from dozens of ground observatories. If patterns emerge, if anomalies persist, if the data coalesce into something coherent, we will know. Here is what you should watch for. First, does 3I Atlas survive perihelion intact? If it fragments, natural comet. Fragmentation is common, expected, boring in the best possible way. If it emerges intact with continued outgassing at the same rate or higher, that is unusual. Large comets can survive, but 3I Atlas is already exhibiting activity levels far from the Sunday. Sustained activity through perihelion without fragmentation suggests either a very robust structure or a composition we do not understand. Second, does the chemical signature change? If post-perihelion observations show iron alongside the nickel, the mystery evaporates. The earlier absence of iron could be explained by differential sublimation, with iron-bearing compounds vaporizing at higher temperatures reached only near perihelion. If nickel remains dominant and iron remains absent, the anomaly persists and demands explanation. Third, does the trajectory deviate from predictions? If 3I Atlas follows a purely gravitational path, matching calculated orbits within measurement uncertainty, natural object. If it exhibits non-gravitational acceleration, changes in velocity not explained by outgassing momentum, then we must consider other mechanisms. Oumuamua showed such acceleration, attributed by most researchers to cometary outgassing, even though no visible coma was detected. If 3I Atlas accelerates despite measured outgassing that should produce different momentum, we have a problem. Fourth, does the nickel emission turn off? If the nickel signature disappears after perihelion or during the solar conjunction blackout, it suggests that the emission was tied to a specific temperature range or a limited volatile reservoir that has been exhausted. That would support the exotic natural chemistry hypothesis. If nickel emission continues at steady rates, regardless of distance from the Sun, independent of temperature, that is harder to explain naturally. Volatile ices sublimate when heated. They stop sublimating when they cool down. Steady emission across a wide temperature range implies either a very unusual thermal profile or an internal heat source. Fifth, Are there any structural changes visible in the highest resolution images? If high-rise images show a smooth, uniform coma with no surface features, natural comet. If they show geometric patterns, regular structures, straight edges, anything suggesting artificial construction, that would be extraordinary and would require extraordinary evidence. I am not predicting that. I am listing it as a logical possibility that must be checked. The problem with 3I Atlas is not that any single anomaly is inexplicable. Each oddity, taken alone, can be argued away. Unusual chemistry, rare but possible. Large size, statistically unlikely but not impossible. Aligned trajectory, coincidental. Nickel without iron, exotic but potentially natural. The problem is the conjunction, the simultaneous occurrence of multiple low probability features in a single object. Statisticians call this the multiplicative improbability. If event A has a 10% chance and event B has a 10% chance and both occur independently, the joint probability is 1%. 3I Atlas presents not 2 anomalies but at least 5, each with probabilities in the single-digit percentages if we are generous. Multiply those probabilities together and you are looking at odds in the 10,000ths or 100,000ths, not impossible, just improbable enough to warrant serious attention. This is why the International Asteroid Warning Network is treating 3I Atlas differently than previous interstellar objects. Oumuamua was gone before we fully understood what we were looking at. By the time consensus emerged that it was interstellar, it had already passed perihelion and was racing outward beyond the range of most telescopes. We got 1 good month of observations, then it faded into the background stars. 2I Borisov gave us more time because it was discovered earlier in its approach, 10 months before perihelion. Astronomers tracked it for over a year, watched it develop a classic cometary tail, measured its water and dust production rates, confirmed it was chemically similar to solar system comets. It was an interstellar tourist that followed the rules. 3I Atlas is breaking rules we did not even know existed. And unlike Oumuamua and Borisov, it is passing through the planetary zone during an era when we have more space telescopes, more ground observatories, more international coordination than ever before in history. We are watching it with instruments that did not exist 5 years ago. James Webb was launched in December 2021, JUICE launched in April 2023. Vera Rubin Observatory began science operations in 2025. We are catching 3I Atlas at the perfect moment in the development of our observational capabilities. If there is anything unusual to see, we will see it. Let me step back and address the question everyone is thinking. Are we alone? That question has haunted humanity since we first looked up at stars and wondered whether other minds were looking back. For most of history, it was philosophy. In the last century, it became science. We built radio telescopes to listen for signals. We sent probes to Mars and Europa and Titan, searching for microbial life. We discovered thousands of exoplanets, confirmed that worlds are common, that solar systems are the norm, not the exception. We estimated that the Milky Way contains 200 billion stars, at least 100 billion planets, and some fraction of those are rocky, temperate, wet, stable, bathed in starlight for billions of years. The Drake equation tells us that if the probability of life arising is not absurdly small, if the probability of intelligence emerging is not negligible, if technological civilizations last longer than a few centuries, then the galaxy should be teeming with minds and machines. The Fermi paradox asks where they are. Why is the night sky silent? Why have we not been visited, contacted, colonized? 3I Atlas is not an answer to that question. Not yet. It might be a comet. Probably is a comet. Most interstellar objects will be comets and asteroids, debris left over from planet formation around distant stars, ejected into the galaxy by gravitational interactions, drifting through the void for millions or billions of years until chance brings them near another star. But here is the thing about rare events. They only seem rare until they happen. In 2017, we had observed 0 interstellar objects. Today, we have observed 3. The detection rate is accelerating not because the arrival rate has increased, but because our survey capabilities have improved. Atlas, Pan-STARRS, Vera Rubin, These systems scan the entire sky every few nights, looking for anything that moves. As they get better, we will find more interstellar visitors. Dozens per year, eventually hundreds. And statistically, if even 1% of those visitors are not natural, if even 1 in 1,000 is artificial, we will find them. The question is not whether we will detect evidence of extraterrestrial technology. The question is whether we will recognize it when we see it. That is why 3I Atlas matters, regardless of what it turns out to be. It is forcing us to develop protocols, to refine our criteria for distinguishing natural from artificial, to ask what signatures we should look for and what instruments we need to find them. Loeb has proposed his scale, a quantitative framework for ranking anomalous objects. Others are developing competing frameworks. This is how science progresses, not through sudden revelation, but through incremental refinement of tools and methods. Whether 3I Atlas scores a 4 out of 10 or a 0 out of 10 on any particular scale is less important than the fact that we are building the scale in the first place. We are preparing for the possibility that one day, maybe not this object, but someday, we will point our telescopes at something moving through our solar system and realize that it should not exist without intent behind it. The next 6 months will tell us a great deal. By the time 3I Atlas passes Jupiter in March and begins its long journey back into interstellar space, we will have amassed more data than we collected on Oumuamua and Borisov combined. Teams at Harvard, UCLA, ESA, NASA Goddard, the European Southern Observatory, universities in Japan and Australia and Chile, they are all analyzing spectra, tracking trajectories, building models, testing hypotheses. Some will argue for natural origins, others will argue for technological origins. Both sides will present evidence. Both will find weaknesses in the other's arguments. That is the process. Messy, contentious, uncertain, but ultimately self-correcting. If you want to stay on the timeline as this unfolds, as observations come in and analyses are published, I encourage you to follow the scientific literature and keep track of the developments. This is not a mystery that will be solved in a press release. It will be solved in papers, in data releases, in incremental steps toward understanding. And here's the question I want to leave you with, the one you should be asking yourselves over the next few months as we watch 3I Atlas move through the inner solar system and back out into the dark. When you look at the evidence, the nickel signature, the size, the trajectory, the outgassing profile, the absence of iron, do you see a pattern, or are we pattern seeking? Humans are spectacularly good at finding patterns. We see faces in clouds, hear voices in static, construct narratives from random events. It is a survival trait that served us well on the African savanna. It serves us less well when interpreting ambiguous data from objects 400 million miles away. But here is the flip side. Sometimes the pattern is real. Sometimes the signal is not noise. The universe does not care about our expectations. It is not obligated to be simple or familiar or comforting. If we are going to explore it honestly, we must be willing to follow the evidence wherever it leads, even if it leads somewhere uncomfortable, especially if it leads somewhere uncomfortable. 3I Atlas is either the most unusual natural comet ever observed, stretching but not breaking the boundaries of known chemistry and physics, or it is something else entirely. Something that requires us to expand those boundaries. Either way, it is teaching us. Either way, we are learning what is possible in a galaxy 200 billion stars wide and 13 billion years old. I have been studying physics for 5 decades, teaching it for 4, writing about it for 3, and the one thing I have learned with absolute certainty is that the universe is stranger than we imagine, and stranger than we can imagine. 3I Atlas might be strange because it formed under strange conditions, or it might be strange because someone, somewhere, billions of years ago, decided to send a message, and we are finally advanced enough to notice it. I do not know which. No one does. But we are about to find out. Watch the data. Watch the dates. Watch what happens when this object emerges from behind the sun in December and we get our next clear look at it. That is when the real science begins. That is when we will know whether this is just another comet with weird chemistry or whether October 2025 will be remembered as the month when everything changed. One last thought. If 3I Atlas does turn out to be artificial, if the weight of evidence eventually tips in that direction after exhaustive analysis and peer review, the implications extend far beyond astronomy. We would know definitively that we are not alone, that technological civilizations arise, that they build things, that they survive long enough to send those things across interstellar space, and that they choose to send them past stars with planets where life might exist. That sequence of deductions leads to a conclusion that should fundamentally alter how we see ourselves in the cosmos. We would be part of a story larger than human history, larger than Earth, larger than our solar system. We would be participants in a galactic narrative that has been unfolding for billions of years, and we just now opened our eyes wide enough to notice. That possibility, however unlikely, however speculative, is worth taking seriously. Because if it is true, if even a fraction of it is true, then the most important discovery in human history is happening right now, not in a laboratory or a particle accelerator, but in the darkness between stars, moving at 61 kilometers per second, wrapped in a cloud of carbon dioxide and nickel, silent, inexplicable, demanding our attention. The countdown is running. 3I Atlas will reach perihelion in 4 days. It will emerge from solar conjunction in 48 days. We will have answers by Christmas, or we will have better questions. Either way, we watch. Either way, we measure. Either way, we follow the data, because that is what science demands. And because the alternative, closing our eyes and pretending there is nothing unusual here, would be the greatest failure of intellectual courage in our history, comment below with your take. Do you think 3I Atlas is simply an interstellar comet with chemistry we have never seen before, or do you believe the accumulation of anomalies points towards something more, something designed? Contact or pattern seeking? The evidence is mounting, the observations are coming, and the answer, whatever it turns out to be, will be written in the light of a moving object that traveled across the galaxy to pass, just once, through our small corner of the universe. We get one chance to understand what we are seeing. Let us not waste it.